All right. Hey, welcome. Happy Cyber Day. Glad y'all are with us today. So we're going to be doing a podcast, just kind of reviewing. So if you're looking and watching, then all you need to do is just write a comment below on the video. So you can just write down hi there or whatever you want and just comment below. That'll just kind of let me know who's here for our podcast. And so, again, if you have questions, please just ask as we're going. Today's online podcast is just going to be about less than 30 minutes. I got a timer already going for my screen for 30 minutes. I want to make sure that I don't give y'all too much work. But again, this isn't work. Again, reminder about the Cyber Day policy. For my class, all you need to do is get that study guide done and turn it in on when we see you on Thursday. Now, I know in my message I did write Wednesday. Actually is to Thursday because I know some of us have that block day schedule. So from my understanding, we'll go back to block day, but we'll see what happens. So let's get it going. Thank you. This is sponsored by Sarah Jewell today. Sarah Jewell Simpson. She sent some couple of questions based off of the study guide. And so let me do let's see, I get over here. Got a nice little setup, kind of off-site broadcasting right now. Trying to figure out how to screen share again. It's been a while since I've done this. Screen share, desktop. All right. So here we go. So first question is going to be based off of number 2 on the study guide. And so looking at number 2, what we're going to be doing is looking at simplifying. So if we look at the study guide, it says simplify, your answer should contain only positive exponents. And so if it should only contain positive exponents, what that means is we got to get rid of negatives if there's any negatives. Not negative values, but negative exponents. And so let me get over here. All right, good. I am backwards. Okay, let's try this. Right side up. There we go. All right, so what we need to do first is we got to think about PEMDAS. And PEMDAS tells us that we do everything inside the parentheses first, followed by exponents, followed by multiplication, division, followed by addition and subtraction. It's kind of a 4-step process. Step 1 is parentheses, step 2 exponents, 3 multiply, divide, 4 add and subtract. So looking here, I'm going to look inside my parentheses. This is pretty much simplified. I mean, negative m squared into the 4th is simplified. But now let's look at to the 5th power. Let's look at our exponents. So I'm going to first take a look at simplifying this part. Now, based off of the power rule, meaning that if I have an exponent raised to an exponent, we will multiply those powers, those exponents. So we multiply those, we're then going to look at 2m to the 5th times negative m to the 10th n to the 20th. And I got 10 by doing 2 times 5 and 20 by doing 4 times 2. Now this negative here is essentially an understood -1. And so what we're going to do is we're going to look at the coefficients of each term. So we'll do -1 times 2. And then that will give us a -2. And then we'll take a look at our m. When we multiply variables, or essentially bases that have the same base, you will add those exponents. So if this is m by itself, it's really m to the 1, 1 plus 10. And then for n, we'll do to the 5 plus 20. And that will give us -2 m to the 11th, n to the 25th. And that is question 2. Next question I had asked by a student was question number 8. Now this is simplifying the radical again. But here we dealt with exponents. Here we're looking at the radical. And so the instructions on your guide for number 8 is the word simplify. Essentially, if you see that word simplify, you're trying to reduce the radical as much as possible. And so in order to reduce it, we are going to first look at this big, large coefficient, 324. Now, the way that we've been doing reducing radicals is we take 324 and divide it by the lowest prime number that we know. Well, the lowest prime number that we know is 2. And so if we do 324 and you divide it by 2, that'll give you 162. If you divide 162 by 2, That will give you 81. Now, does 2 go into 81? It does not. And so what we can look at next is we can look at the value of 3, which will be 27. 3 also, 27 divided by 3 is 9, and 9 divided by 3 is 3. Now, the goal here is look, what is this root? Based off of the root, that root will tell us what grouping size that we need. So our grouping size is 4, meaning that I need to find a group of 4. So there's 1, 2, 2, 2, but there's not really 4 2s. But here I have 1, 2, 3. I have 4 3. So I can take that group of 3, or that group. I can take the group of 4 of 3s and pull that outside of the radical. Now, with those 3s, when I pull them outside the radical, that's essentially doing, I'm leaving the 6 here, and then I'm multiplying that by the 3 that we pulled out. Now, with the root here, what's left over? These 2's. So I'm going to have a 2 left over, followed by another 2 left over. And so now I got 2 times 2. Now this m squared here, I'm going to look at the root power. Can 4 go into 2? It cannot. So then I'll just leave it as an m squared. Now can 4 go into 8? If we divide 4 and 8, 4 goes into 8 2 times, which means that since 4 can go into 8 2 times, we'll pull out 2 ends. Because essentially this fourth root means that whatever is under here is represented by things that multiply 4 times in a row. So here, this is 3 times 3 times 3 times 3 times 2 times 2. Now, when we simplify this, we should get an 18 n squared to the 4th root of 4m squared. Voila, and we're done. And that was number 8. Next question a student asked was number 9. Number 9 and number 8 is essentially the same thing, same concept. We're trying to simplify the radical. And so if we're trying to simplify the radical, we are going to first look at our root. Our root in this case is 3. Now, if the root is 3, that means I'm looking for groups of 3. So let's look at 243 and see if it's divisible by the lowest prime number. So what's the lowest prime number we know? Again, it's 2. But again, 2 doesn't go into 243. So let's try 3. If we try 3 here for 243, 3 would go into it, and that would be 81 times. And then we'd have 3 and 27, 3 and 9, 3 and 3. Again, every time the 3's, I just keep bringing it back. But I'm doing 243 divided by 3 to get 81. 81 divided by 3 to get 27. 27 divided by 3 to get 9. 9 divided by 3 to get 3. We need to look at our group size. Again, that group size is based off this root. So I need a group of 3. 1, 2, 3. Now this negative 9 is staying on the outside. And I'm going to multiply it by the 3 that I pulled out. So if you have one group of 3, it's not going to be 3 times 3 times 3. You're only pulling out one of them. And so that leaves left behind, we have 2 3's left behind. Now, again, looking at the roots now, or at the exponents, we got x cubed. How many times does 3 go into 3? Once, so we'll pull out 1x. And then how many times does 3 go into 6? Twice, so that'll be y squared. So then our final answer will be negative 9 times 3, which will be negative 27. Xy squared times the cube root of 9. Now this isn't the square root of the 9, it is the cube root of 9. And that should be good for us. And again, if we finish early, I might stop the podcast early, but we'll see how it's going. Again, if you're here watching now, just leave a comment below if I'm going too fast or anything like that. I appreciate the 6 people that are watching. Glad that y'all are here with me. And so next thing that we're going to be looking at is we're going to be looking at multiplying. Now, again, to multiply, we're looking at these roots. Are they the same? If they are the same, we can treat it as multiplying 35v to the 4th and multiply that by 49v squared. If they are the same, we can multiply them. If they're different, then we'll have to turn into exponent mode and do a couple things through that. But in this case, let's just leave it as is. And so that will be 35 times 49. And so when we do 35 times 49, that's going to give us the value of 1,715. So you're like, Mr. Lawless, that's a huge number. What are we supposed to do with that? Well, let's get there. First, we multiplied 35 times 49, and then we multiplied the v's. V to the fourth times v squared, if we add those exponents, is v to the sixth. So with 1,715, I know it's not divisible by 2 right off the bat. So I'm going to view if it's divisible by 3. In this case, it is not. So let's try 5. For 1,715, we're going to see if it's divisible by 5. If it is, let's get 1,715 divided by 5, which will be 343. And now 343 is a prime number. And so with that being said, or it's not a prime number, I'm sorry, it should be divisible by 7. So if we do 343 divided by 7, that will be 49. Divide that by 7 again, that will be 7. We're looking for groups of 4. Are there any groups of 4? There are not. So we can't simplify 1,715. I want to show you a shortcut. Let's say this 1,715 confused you. If you break up 35, we know 35 to be 5 times 7. We also know 49 to be 7 times 7. Notice the values that we found, 5, 7, 7, 7. We found all of those factors through these. So again, you don't have to multiply them. It's just one way to do it. So let's look at our variable. For our variable here, we have it where we have the power of 6, the root of 4. So how many times can 4 go into 6? 1 time. And if it goes into it 1 time, what's left over? A squared. And that is our answer. Moving on, this was the last question that I had from a student, and then I'll just show a couple of examples just in case we have any questions. And so looking at 32 to the power of 6/5, remember that this is our base, this is our power, and this is our root. Meaning that if I am going to turn this into radical mode, as it states in question 25, or 25 it says really simplify, but to simplify it, you can probably turn it into radical mode. That's going to be the 5th root of 32 to the 6. Now, if we're doing this by simplifying only, it might be easier to rewrite it as the 5th root of 32 to the power of 6. So let's look at 32 and see how that simplifies. I know 2 goes into it. 2 goes into it 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. And 2 goes into 2 times. How many do I have? 1, 2, 3, 4. I got all 5 right here. And so what that tells me is the 5th root of 32 is actually 2. So now I just need to find out what 2 to the 6th power is. And if I do 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32, times 2, which will be 64. And so that's the last student question. So before I open it up to my guided lesson, for the 7 people watching now, I would like for you to comment on any questions that you would like me to work on the study guide before I go into my own thing. And my thing will probably last 10-ish minutes. So I'll give you all about 30 seconds. If I don't see anything when it says 1600, I'll move on to the next one. All right, it says 1600. I see no comments below, and I did not get any text through the remind map either. So let's get going. So let's talk about how to rewrite. If it says write the expression in radical form, where that means we're going from exponent form into radical form. So that means I want to take that 7 to the 5 over thirds. I want to rewrite it as in that radical form. So if we're rewriting it, the base is our root, not the base, sorry, the denominator of the exponent is our root. The base is the value underneath the radical, and then the power goes right there. Plain, simple, easy, not too bad for us. Let's say we do the opposite thing. So if this is the square root, remember if there's a square root sign and there's nothing there, imagine that a 2 is there. And so when we rewrite this into exponential form, so that's essentially going from radical to exponential form, what we're going to do is take that square root, put the base here. So we have the base raised to the power over the root. So it'd be 7 to the 3/2. And then that would be it. So that's just kind of going into different forms. Those are the nice ones for us. And so one thing I want to talk about is rationalization. So rationalization means that if you have a radical in the denominator, we need to get rid of it. And so there's two different ways to get rid of it. One, if you have like 2 divided by the square root of 3. If it's just a radical by itself, you can just multiply the top and bottom by that radical. So then the denominator will leave. And so then you'd have that. Now, with that, this is a little different. Once you're adding or subtracting in the denominator, we want to change it up a bit. And so to change it up a bit, what we can do is look at that denominator. I have a 2 minus square root of 3. I actually want to make it where it will be a 2 plus square root of 3. This is known as the conjugate. You want to multiply it by that conjugate. And what you do to the bottom, you need to do to the top. So what we did to the bottom, we'll do to the top. And so for the numerator, what we'll do is we'll do 5 times 2 to get 10. 5 times root 3 to get 5 root 3. And that'll be for the numerator. For the denominator, what we'll do is we'll do FOIL. First, essentially pretend that both of these are in parentheses. First, this will be 4. Outer, which will be plus 2 root 3. Inner, which will be minus 2 root 3. And last, which will be negative root 3 times root 3, which is root 9. And that simplifies to 3. Now, these two inner values cancel. And so for the numerator, we'd have 10 plus 5 root 3. And then you'd have 4 minus 3, which is 1. And to really simplify it out, we'd get 10 plus 5 root 3 as our answer. And so one thing that I've noticed, I got a text from, looks like Milani. She's calling out number 3. So let's take a look at number 3 here on the study guide. So for the study guide on number 3, we're looking at, actually, I think that was one of the ones I wanted to look at. Yes, it is right here. We kind of work one step at a time. Remember, we're doing that PEMDAS, everything inside the parentheses, then the exponents, then multiply and divide, add and subtract. So if we look here, are the parentheses, everything in here simplified? No, it is not. And so to simplify it, we're going to have what's negative 2 over negative 2. That will be the value of 1 over 1, essentially, because negative 2 over negative 2 simplifies to 1. That x to the negative 4, well, if anything that's negative, we know goes to the bottom. Y cubed, we can leave there. And then what's y to the 0? Y to the 0 is anything to the 0 is 1. So this is where we're at so far. The next step for us to do is look at the exponent. What do we notice about this exponent right here? It's negative. So rather than raise everything to the negative 2 power, we're going to use the property of negative exponents, which means we're going to flip it. And when I say flip it, we'll flip 1 over x to the 4th y cubed, 1, essentially switching this. And now rather than it being to a negative 2, it's actually to a positive 2. And so with that, I'll simplify this inside just one more. I'm going to get rid of those 1s because, dividing by 1 is essentially the same thing as multiplying. So those will essentially cancel out. And so if we square it, that means that we're going to multiply the 4 by 2, multiply the 3 by 2. And so that will give me x to the 8th, y to the 6th. Any questions on this one? Again, you can question by writing comments on the video. Again, for those joining or might have just joined right now, the test is on block day Thursday. So I might have said yesterday because I kind of sent it out to all my classes. I will be seeing some classes tomorrow if we have block day schedule. And Thursday is our test and for 6th and 7th period. All right, I don't see any questions or comments through Remind, and I don't see any questions or comments through the YouTube video so far. And so what we're going to do is we're going to take a look at some more problems. And so for these more problems, let me go way over here. Where is it? There we are. Let's look at the next one. So for this, we're going to be looking at adding radicals. Joseph A is typing in the video. All right. Before I do that question, let's hear what he asked about number 4. All right, let's take a look at number 4 then before we talk about, well, we'll do this adding radicals first and then we'll do number 4. So looking at adding radicals here, in order to add or subtract radicals, what we got to have is we got to have the same root, meaning that you have to have an x plus an x, or a root 2 plus a root 2, a root 3 minus root 3. They have to be the same radicand, or same number underneath the radical. And so what we can do for number 15 on the study guide is I want to reduce 18. So if I try and simplify 18 here, let's see, 18 divided by 2 is 9, divided by 3 is 3. So we can rewrite 18 as 3 root 2, but this is really 3 root 2 times negative 3. And so that's going to give us a negative 9 root 2 plus 2 root 2, which when we add these two, you're really focusing on just the number in front of the radical. And then that would give us a negative 7 root 2 as our answer. And so let's take a look at Joseph's question. Joseph's question was number 4. And number 4 is y x to the negative 3 over x to the 0, y to the 4th power. Now remember, PEMDAS is the key, meaning that we need to simplify everything in the parentheses first. So there's no parentheses up top, so we'll just leave that as y times x to the negative 3. And then for the denominator, we'll look at x to the 0. What's anything to the 0? That's right, it's 1. And so this would simplify to the y to the 4th power. Now we can use exponents. Now here we have an exponent here, so this will be x or y x to the negative 3. Now y to the 4th raised to the 4th power, that means we're going to multiply those. So that's actually going to be y to the 16th. And again, one thing we cannot have ever is we cannot have negative radicals. And so we can't have negative radicals, so it's y divided by y 16th x to the, y to the 16th times x cubed. Now the question is this fully simplified? No, I have a y up top and a y on the 16th. Remember that we subtract for this. So if I want to get rid of that y, I can subtract, and so then I'd get 1 over y to the 15th x cubed as my answer. Are there any other questions? We have about 5 more minutes. I've kind of worked through all of the ones that I had planned, and I'll give it till it says 04:30. I'll give you all 1 more minute to ask any questions that you might have. And if there are no questions, then I will end our podcast. Again, you can still reach me through email. A reminder about our test. Test will be on block day when you get back. You're welcome, Joseph. Thank you for letting me know. And again, the study guide key is on my GAC, along with a blank copy of the study guide. And if you take the study guide, take it like a test, man, you'll be golden. Please work out number 1. Thank you, Abby. Let's see. Number 1. Yeah, I can work out number 1. Let's take a look at number 1 here. So number 1 on the study guide, let's see, number 1 says that we're looking at negative 2 ba to the 5th times ba to the 4th squared. Remember, PEMDAS tells us that we need to simplify everything inside the parentheses first. So to simplify, what we're going to do, now this times ba, that's really like a times 1. So we'll do negative 2 times 1 to get negative 2. We'll do a b times a b. Remember this, if it's a b by itself, it's to the first power. So we'll add those 2. And then for the a's, since we're multiplying those, we will add those as well. So then that's going to give us negative 2b squared a to the 9th. Now we can do our squared. For the square here, we have it where this is 2 to the 1, so we'll make 2 squared, b squared, multiply those exponents, So negative 2 squared. This is not just, it's squaring this whole value. So what's a negative times a negative? A positive, so that would be a positive 4. Then we would have b to the 4th, a to the 18th. If you're OCD like me, you can rewrite it as a to the 18th and b to the 4th, just so it's alphabetical order. But either one of those are correct. Any other questions that we might have? Again, you can comment via remind through texting me back, or you may comment via the video. Feel like that's been, let's see, number 10, por favor. All right, let's look at number 10. Number 10, this one will probably be our last one for the live stream, unless there are any more pressing questions I can answer. But let's make it our last one, see what happens. So for number 10 here, 10 is, looking at 10, 10 is 7 times the 6th root of 1024 into the 6 times the 6th root of 112 into the 4th. And so one thing that might be helpful for us is to just list out all of the factors, because notice that they are the 6th root. And so when we multiply this will be essentially 1. So then that'll be 7 6th root of 1,024 into the 6th, and then 112 into the 4th. Rather than multiplying these two, what I'm going to do is find my factors. So I'll look at 1,024. Factors of 1,024, if I divide it by 2, that's going to give me 512. If I divide by 2 again, that will give me 256. Divide by 2 again, that will give me 128. Divide by 2 again, that will give me 64. Divide by 2 again, that will give me 32. Divide by 2 again, and that'll give me 16. Divide by 2 again, and that'll give me 8. Divide by 2 again, and that'll give me 4. And divide by 2 again, and that'll give me 2. Wow, that's a lot. Now, if we can find a group of 6, we can pull that out. So let's look. 1, 2, 3, 4, 5, 6. Because I found 6 2s, I am able to pull out one of those 2s to multiply by that 7. Now let's look at the factors of 112. If I look at the factors of 112, I could go 112 divided by 2 to get 56. 112 divided by 2 to get 28. 112 divided by 2 to get 14. Divided by 2 to get 7. Now here's the thing. I'm going to go back just a half step here. When I find all these factors, that's essentially, if I do that, that'll be 2 times 2 times 2 times 2 times 2 times 2. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 2 to the 10th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of those 2's give us 1,024. If we continue to multiply the other 2's, where it's 2 times 2 times 2 times 2 times 7, that represents these. And so now I just need to find groups of 6. 1, 2, 3, 4, 5, 6. There's a group of 6. 1, 2, 3, 4, 5, 6. There's another group of 6. And so to factor my value underneath the radical, I'm going to have it where it's 7 times the 2 factored out from this group times the 2 factored out from that group. And then that will leave me left over whatever 2 times 2 times 7 is, which should be 4 times 7, which is 28. Now let's look at the n into the 6 times n to the 4th gives me n to the 10th. So how many groups of 6 go into 10? One of them does, which leaves 4 left behind. 7 times 2, 14 times 2 is 28. So our final answer will be 28n times the 6th root of 28 into the 4th. So that's kind of a little over 30 minutes. But again, thank y'all for watching. I appreciate it. I'm now going to end the podcast so that y'all can enjoy the rest of your Cyber Day. If you have further questions, please shoot me an email, and I will answer them as fast and quickly as I can. Thank you, and go Spartans.